ladies and gentlemen, we're ready to take a look at lesson 8.5. It's area of parallelograms, and we also throw in area of rhombi or rhombuses. So our goal is to be able to work with parallelograms. So we're kind of working our way through the different polygons that we've studied this school year. We studied rectangles and squares, so we found the area of those. We studied triangles, we found the area of those. The other thing we studied in chapter 6 was parallelograms, so now we're going to find the area of that. So vocabulary. The base of a parallelogram is one side of a pair of parallel sides. So if we think of a parallelogram, let's see how far down I can move this. If we think of a parallelogram, these are parallel sides, and then these are parallel sides. All right, so we could call this a base, okay? Or we could call this a base, just depending on where we're at. And so, or what view we have. And so what determines what we use as our base is where the height is put. So the height is the shortest distance between two parallel sides, which means it's going to be a perpendicular line. All right, so in this case, when they draw this in and put the height here, I know that this is the height and this is the base that I'm going to use. Okay? So it just depends on where the height is drawn in. So let's take a look at some of these and see what we can do. So the area of a parallelogram is the product of a base, because we could have two different bases. We could have this base, or we could have the other base, and its corresponding height. And so we need a perpendicular line, perpendicular segment to hit one of the sides of our parallelogram, and then the side that it hits, that's where our base is. And so the formula for that is just base times height again. But the difference here is the height is not a side. So it's kind of like your triangles, where your height was given inside or outside of the triangle. It's going to be the same thing for your parallelograms. So we want to, for our follow-up, for each, draw a picture, and we want to write the formulas. We're going to save this activity because I want to visualize this with you guys in class and show you guys why we can compare these two formulas. All right, so example 1, we want to take a look at finding the area of a parallelogram. We're going to substitute 9 for the base. And so even though this 6 doesn't hit the base, it comes down towards the 9 to create the perpendicular. So 9 is our base, and we're using 6 for that height. So the height can either be drawn outside, or we could have drawn 6 inside of that. So we do 9 times 6, which is 54 meters squared, or we could say that the area is 54 square meters. We need to be able to recognize both those labels as meaning area. All right, so now we're going to find the height of a parallelogram given the area. So this is going to look very similar to what we've already done with rectangles and triangles. We're going to take an area of 78 square feet and find the height. So we're going to start with our formula, write that down, area equals base times height, substitute 78 for A, and substitute 12 for B. So I have 78 is equal to 12 times H. I have to divide each side by 12, and so we do 78 divided by 12. It is okay to get a decimal. So we get H is equal to 6.5. So my answer is 6.5 feet. Do not forget your label. So these parallelograms follow nice in step with what we've done. And so here you guys have, you have 6 checkpoints. You are to do now. All right? For full video credit. So, ladies and gentlemen, those of you who always say, oops, I forgot, pause right now. This is going to look like example 1. This is going to look like example 2. All right? So let's take a look. Now we have the area of a rhombus. So the area of a rhombus is equal to 1/2, so it's equal to half the product, which means we're multiplying the lengths of the diagonals. So we're not going to use any of the side measurements of a rhombus, but what we're going to do is study these diagonals. And what we know is that these diagonals are not equal to each other. They do bisect each other, but they're not equal to each other. So what does this look like? We're going to take 1/2, and we need to multiply the diagonals. Those are going to be denoted as D1 and D2. So 1/2 times D1 times D2. So it's kind of similar to your triangle formula, where you got 1/2 base times height. Here we have 1/2 D1 D2. So what does that look like? Well, they're giving me my measurements in a little bit different ways so we can prepare. They go from 10 from side to side, which means the first diagonal is 10. They then go vertically, top to bottom, with the 14, which means my second diagonal is 14. So D1 and D2 are just 10 and 14. Now, some of you are doing some mental math, doing 1/2 times 10 and getting 5, and then doing 5 times 14. You can do 10 times 14 and get 140 and then multiply by 1/2. Whichever is easiest for you, or just type this all into your calculator, but we get 70 square inches, or 70 inches squared. Now, if we look at our second example, this 6 is for the top, and this 6 is for the bottom, which means this first diagonal is 12 meters. I have 9 to the center and 9 going across, so that means this second diagonal is 18 meters all the way across. So I'm doing 1/2 times 18 times 12. Once again, regardless of how you want to do your multiplication, those three values have a product of 90 square meters, or 90 meters squared. So you guys have 3 checkpoints. I'm going to do number 8 with you now, and then you guys will do 7 and 9 on your own. So 7 and 9 are to do now, and we will check in class. Let's do number 8 together. I have 2 from here to here, which means D1 is equal to 4. That's 2 plus 2. I have 3 here and 3 here. That means my D2 is equal to 6. I got that from 3 plus 3. So my area is 1/2 times D1 times D2. So I have to do 1/2 times 4 times 6, which is equal to 12. And then it's meters, so 12 meters squared. All right, you guys should be able to do 7 and 9 on your own. That's it for parallelograms and rhombuses. Notice the algebra that we do, the math that we do, the simplifying looks very similar each time. What we're going to have to work on is keeping these formulas straight. All right, we'll see you tomorrow. Have a great day.